Hello, this is a presentation of how we made a real-time Kalman filter using data from the Cognite data platform. In this case, we went to operational intelligence. We made a graph, this one, with several variables connected to the scrubber, which we identified from the PNID, which we can download via Python. This is discussed in the report. We'll not discuss this here. Then you can simply download the data. We used 5 seconds as the sampling time. We picked some dates for the start and the end of the data collection. Then we used the comma delimiter and downloaded as CSV. This data was then imported from the Excel document over to another Excel document where we parsed the CSV file into an Excel spreadsheet so that we got it in Excel format. Then after changing from dots to commas, because the MATLAB reader needs to have that format, we simply got this resulting data, Excel data. Then we used simple XLS read command from this. And here you see all the fields we imported from the spreadsheet. Here you see how much of the data is training data. We used 80% in this case. Download the spreadsheet, the control value. Then the control value had a lot of not a value, so we had to assume that in this case that valve only reported deviation over a certain threshold. So we then assume that if the value was none, the value should be set equal to the last control value. Then we find the mean of the data set and subtract this just to center the data. And then we split the data into estimation and test set. Then we read the outputs. We do the same sequence. We define some parameters for a model. We tested several states, but only one was needed. If more were used, it only introduced noise into the dataset. We then define the horizon for the prediction, and we assume that it was closed loop. This is not directly closed loop, but the change in the valve is connected to a pressure controller, and it would have a lot of feedback into the level in the scrubber, which we are to estimate. Then we use the DSR.E method from David Ruscio. Here we get the state space model, A, B, D, E, and the Kalman filter matrix. When we're using closed loop, E is 0, so this is not used. And of course the initial state. Simulate the data, we add back the mean, and then we test the Kalman filter on the entire dataset, and we plot it. It's running. Here you see the state. Something's happening here. Okay. Yeah, same in the output. Something's happening around the same place. This is the estimation, control value, I mean. And this is the model. Clearly not the best fit, but we see that some trends are surely present. So we can capture some dynamics. The model is also most likely non-linear, so couldn't capture this with this method. That was that. Now I will show you this running in real time using LabVIEW Python integration. So here we are simply starting a Python. We've defined a one class, one Python file containing a lot of function that calls a predict class which contains the Kalman filter. So this just gets the data, data. This makes the prediction, uses the Kalman filter, and this gets the state. Get some data here, yes. Again, something happened with the plots. Take some time, loop has to finish. It might have to stop. Try again, something has happened here. There, some plots. See the state, you see the outputs. So the sampling time is 5 seconds. No, actually it's 1 minute now. So that was the issue. Now we'll see if we get some more estimates. Here we go. So yeah, the Kalman filter is just going towards the estimated, the measured value, as it doesn't seem to change. That's that. How to implement a simple Kalman filter on data coming from commit.